Hello. Hello and welcome to a presentation with a bit of a perhaps aggressive title, I don't know. The title says, before you select a tool, you already have made the wrong decision. Some of you perhaps thought, what is this? What is this about? And I'm going to explain during this session what exactly, or the sentiment I try to bring over with this title. And, when we talk about tooling, good tooling, correct tooling, whatever adjective you want to use with it, it's not an option. It's not a detail. For so many people, they consider tooling a bit as it's a detail, and we shouldn't spend too much time on it, and so on. And what I would like to do during this session is try to convince you, if needed, that tooling is really a driver for how a machining process behaves technological, the performance, how from an economical perspective, how efficient the operation is in delivering what is wanted, the correct work pieces at the pre-calculated price, and so on, and how tooling also is a serious driver for being able to call production sustainable, and have circular principles implemented. And I want to put that in the correct perspective. And this presentation is not about details and stuff like this. I really want to show you, to demonstrate you that tooling as such in a company where machining is a major process in production deserves, yeah, I even dare to say, boardroom attention. Um, and of course, I'm not alone here, and luckily, I'm not alone here. I have two people here with me. Perhaps you noticed we started a little bit late because there were some issues with the system, and it's always good to have experts around you when there are some issues with the system. And with tooling, perhaps it's the same thing. And this session is the first out of 5, because this subject, tooling, is so wide, is so vast, that handling it in 1 hour is really impossible. This first session is I would say, the more philosophical session, uh, about what is tooling, why is it so important, how should we look upon it in a very general perspective. And in later sessions, then we go more in depth into the real practical stuff. What is management's contribution to tooling? What's the role of engineering in this whole picture? What about the operators? What is their role in this play? And the last session is about a very crucial thing, and that is that tooling as such, how we handle it, is a circular thing. It's not linear. We first do this, and then we do that, and next we do that, and that's it. No, it should be constant between the different steps. There should be feedback. And that's why I call tooling circular, because that feedback is so important. Now, if you allow me to give you an example, imagine that you want to buy a car. You want to buy tooling, but let's start with a car. You want to buy a car, and imagine you go to the garage, to where cars are sold. The guy asks you, what do you want? And you say, I would like to have a discussion about the tires of a car. Uh, that would confuse that salesman completely, in a sense of, he thought you were here to talk about the car, and you want to talk about the tires of a car. But you know how silly it sounds. That is exactly what a lot of tooling engineers and operators and production managers do when they talk about tooling. They start talking about the carbide grades, or the geometries, or the nose radii, without talking about the big picture. Because tooling is a lot more than tooling features, than the details, the carbide grades, the geometries. Tooling as such, it's really the thing that holds everything together in production. And if you want to have a technological stable production, if you want to have a sustainable production, if you want to be efficient and so on, tooling could be the most important thing there is. And in this session, that's what I want to talk about, not the details. We are not going to discuss carbide grades. We are not going to discuss different geometries and so on. We are going to talk about the big picture. What's the role of tooling in a machining production, in a machining company, perhaps I should say? Because it's something I learned over the years that 1/3 of the money spent on tooling is too much. I'm not going to say is a mistake, but it's too much spent. And not because tooling is expensive, because a lot of people will say, yeah, of course, with the prices of tooling, of course, we spend too much money on it. No, it's not about that. And it's not about bad. People say, yeah, of course, you buy quality, lesser quality, and then you need more tools, so you need to spend. It's not about that either. It's about that we spend too much money on tooling, which we don't need. If we would have started at the correct level, taking decisions about what tools do we need in our production. And let me start with the elephant in the room. And this session, I would like you to comment here and there in the comments on certain things, because in the past I was regularly doing kind of enquetes with people. What do you think about this? What do you think about that? What's your opinion on this? What's your opinion on that? I would like to do it here also, but as this is a digital thing, put it in the comments, your opinion on something, because the elephant in the room, the question I have here, and I give you a couple of seconds to think it over, is in your company, who is actually selecting the cutting tools? Who takes the decisions about what tools are needed in production? Who decides on what do we need? And you know, and perhaps I'm going to shock some people now, and I hope in the meantime some of you had the time to fill some stuff in the comments. Would be very interesting for me to see that after the presentation. But the elephant is, are you selecting your own tools? Or do you count on your suppliers to select the tools you need? It's a bit confrontational, perhaps, asking that question, but if the answer you give starts with a logo of a tool supplier, that's the company selecting my tools, instead of a person, it could be that you have a bit of a problem when we talk about toolings. And over the years, and I'm close to a lot of years in the machining industry, my experience is that too many companies let their tool suppliers decide the tools they need. And if I take a bit of a comparison, like with my car, it's like you go to a shop where they sell electrical stuff, washing machines and televisions and so on, and you enter the shop and you look at the salesman there and you say, I want to buy something. What do you advise me to buy? People say, that's stupid. Yeah, but that's often what people do when it's about tooling. And there's nothing wrong involving suppliers in the process. Once we start talking about filling in details, then we have to count on experts. But the first step, the core step, the real first thing, what are good tools for our company, is not a decision to be taken by suppliers. It's a decision that needs to be taken by the responsible people of the company that needs the tooling. And in that respect, here I would like to say, if I start with my first question, who actually selects your cutting tools? Well, people, it's time that you take back control, that you take back responsibility for this at the first level. And tooling as such deserves board level attention, far before anybody should start looking into catalogs. And that was a bit what I tried to say with the title of this presentation. When I ask people, when do you select tools? When do you start the process of tool selecting? What's the first thing you do? A lot of them say, I take a catalog. But that's wrong. A catalog you take in far later in the process. The first thing is deciding on what tooling is needed in the company, and that is management. That is board level attention, and things like, yeah, we have already a lot of tools in the workshop. You use what we have, and that's good enough. That's not really a tooling strategy. And in that respect, I would say a lot of companies don't really choose tools. They inherit tools. The tools are already in the workshop. Use what we have. It's a strategy, but I don't know if it's the strategy you prefer here, because tooling is, as I said, it's the closing thing. It's the thing that keeps everything together. But tooling, out of all the equipment you have in your production, it's that little cutting edge that cuts metal. The actual machining process is done by 12 millimeters of carbide or whatever cutting material you use. That's how important it is. If it fails, the whole process is down. Yet, for a lot of people, they do not really recognize this importance. And most probably the reason for that is that if you look into cost structures, tooling is representing only a small amount. And since 40 years, I hear tooling is between 3 and 5%. Since 40 years, I'm also discussing about that number, 3 to 5%, on what is it based. I suppose once somebody did an exercise and came with that result. But anyway, 3 to 5%. And for a lot of people in a company, especially when you talk about management, they look at the cost structure in their company and they see some parts are very, very big, the machinery cost, the salary cost, material cost, and then they see somewhere a 2, 3, 4, 5% thing, the tooling, and they say, yeah, that's not my biggest concern, that 3%. And they do not realize that 3, 4, 5, whatever percent is the thing that influence directly the 97 other percents. Because if you go for the wrong tooling, that suddenly means in a hidden way, it's not directly obvious, but in a hidden manner, the wrong tooling is going to increase costs, downtime in machines, poor quality of finished work pieces, deliveries where you are too late, so unhappy customers, and so on and so forth, while correct tooling decisions. And I bear in mind, I'm not talking about carbide grades. So I'm talking here about the tooling system, the tooling concept, the tooling model you decide for your company. That will create a stable process. That will create perfectly, very correctly finished workpieces that give you efficiency, productivity, all the things you want, And if you talk about tooling, if tooling is on your desk, if tooling is something you are occupied with, remember two things. Tooling is the only point where all the other stuff you do in a machining process comes together. Tooling is where the workpiece material is in contact with all the equipment that's going to transform the rough workpiece into a finished workpiece. Whatever investment you make in machinery, in people, in building, it all comes to that 12 millimeter of cutting material in contact with workpiece material. It's truly an extremely important lever for whatever your objectives are with your company. On the other hand, if you look from a direct cost perspective, if you look from a purchasing cost, tooling is very often treated as consumer goods, as consumables, not strategic important. It's you can leave it in the hand of whoever. This is not for management type of thinking, and that's wrong. Because all the issues leading to unfulfilled KPIs in your company, when we talk about machining, most of them can be brought back to the tooling. Underperforming processes, workpieces that are not correct, issues with sustainable whatever. Most of it goes back to the tooling. And I always call that the ripple effect, the economical ripple effect of tooling, because if you have two tools, a good selected one and a not so good selected tool, and if you compare the two, if you ask people what will be the difference between a good tool and a not so good tool, they start talking about tool life and that type of stuff. But that is part of things. But it's much wider. Your cycle time is going to be affected by the type of tooling you select. The scrap rate, how many what you see here, the numbers, it's an example. It's something I had personally a number of years ago, where we were discussing about what is a good tooling concept, what is a less good tooling concept, and that's where these figures are built on. The reliability of a process, if you have a lot of breakage of tooling, that's going to jeopardize the reliability of your process. That leads to downtime costs, which are unacceptable high. The cost per part in the end, the finished part, the thing the customer, your customer needs to pay for is very heavily influenced, and so on. So it's much more than just tool life will be better, tool life will be longer, tool life will be shorter if we start to compare tools. And there are three elements we need to talk about here. You have, if we talk about tooling, there is of course the technical performance. That's the thing everybody is thinking on. That's the thing a lot of machining experts are discussing about. This is the thing about all the features, the geometries, the carbide grades, the dimensions, the angles, the cutting angle, whatever, all those technical features building up to be a tool. And that is going to give you a technical, well-performing or lesser-performing tool. Now, you have to think a little bit wider than traditional long tool life, short tool life here. You have to think also in terms of stability. In which or to which level is a certain selection of features you make, tool features, leading to a stable, reliable, predictable process or not. It's not just by unique performance. That one cutting edge in that one situation is the very best we can have. The question is also about repeatability. Can I repeat that performance time after time after time? Plays also a very important role here. But next to technical performance, there is economical performance, the contribution a tool gives to the economic targets you have with your company. And here especially, again, I bring the attention on when we talk about economics, people think in terms of costs, and they say, but tooling is 3, 4, 5%, come on now, let's, that's the purchasing part. But the performance part, also in money expressed, that 3% of the tooling purchasing cost is affecting all the other costs. in the process. And if you want, from an economical perspective, to evaluate tools, you have to take it far beyond pure purchasing cost. You have to look at the full process. And then we can evaluate tools. A good one, or in the sense it contributes more to my economical targets, or a lesser tool. And the third part is the sustainability element, because if you look to technical performance, is a tool reliable? If a tool is not reliable, what will happen is that a number of workpieces will be scrapped or have to be reworked because the finishing is no good. The tolerances were not met. If from an economic perspective, you want to speed up processes, to minimize time, to increase productivity, it's all very nice for me, but it introduces kind of a risk element, a risk factor in production. And a risk factor means that there is a risk that you destroy workpieces, that you end up with scrapped workpieces, that you end up with workpieces where rework is needed. And if I look now to sustainability, circularity, in machining, most probably the largest limiting factor on sustainability is scrapped workpieces. Because you spend so much money on buying materials, production costs, people costs, engineering costs, and all of that to end up with a workpiece of no value. So, scrapped workpieces, to a minor extent, but anyway, workpieces that need rework are, if sustainability is an important element for you, if economics is an important thing for you, you have to keep those under control. So when we start talking about tooling, there are three dimensions here to consider. You have the technical performance, you have the economical aspects around tooling, and you have the sustainability thing. But all of these together are still not enough to decide what is a good tool, and I hide it a little bit, a good tool for your company. Because we have to talk with two words here. I think I'm not exaggerating if I say that every tool in a catalog is a good tool. Whatever supplier, I don't think anybody is supplying bad tooling anymore today. But that doesn't mean automatically that all those good tools are good for your company. And for that, we need a little bit more. And in this respect, the three dimensions I'm talking about, when people are discussing what is a good tool, and a number of people will go for the cheapest is the best. Tools are not important. Tools do not cost so much. And so why spend a lot of money if we can reduce it even further? Cheap is good. If you go back now to my three dimensions, technical performance, economic performance, and contribution to sustainable production, cheap tooling from a purchasing price perspective is a very dangerous way to go. Other people say, tools, I'm a manager, I'm so busy with important stuff. The operators should decide. They are the experts. And somehow I agree with that. Operators are or should be experts in using tools, but selecting tools, I don't think we should leave in the hands of experts. And again, I'm not discussing about details now, like carbide grades and so on. I'm talking about the overall concept of the basic tooling as you see it for your company. Operators are experts and they play a role in this. We will see later on that operators are the group of people that needs to make sure that the selected tooling works. But selecting in the first place, I don't think it's the role of an operator. And the third thing, we count on our suppliers. We have a good relation with our suppliers, and they should decide what we need as tooling. Also here, if you as management have a clear picture and communicate that picture of what a good tooling concept is for your company, what you expect from it, then you can count on your suppliers. Of course, then they have to help you, then they have to fill in the details. But making the basic choices is up to you, because tooling is not a detail. And if I put it a little bit in production management now, if we talk about the quality of production, there's something which we call production excellence. And production excellence is how do you organize your production? So, and you can make it a very complex definition or a very simple definition. For me, production excellence is very simple. That you organize your production, that you use a production technology as such that for a certain aspect you decide which one you are much better than your competitors. That's production excellence. People can say, for me, delivery is key, because that's what my customers expect from me. Well, if you organize your production as such, if you use the technology in your production that leads you to be a reliable supplier that respects delivery times, that's production excellence, if that is your goal. And if you look to machinery, one could say, wait, if I go back one slide, a machine standing still, the machine to the left, the red one, that's a very not so nice situation. You invested in a machine and you are not using it, but that is not normal. I dare to say not normal here. Machines should be running. The machine to the right, the green one, is the machine running, making workpieces in an optimized way, whatever criteria you wanted to optimize. It's the two situations in the middle. The machine is turned on, but it's not producing, or the machine is producing, but in a not so efficient manner. That's the two problematic situations when we talk about production excellence. And if you look in reality, and it's not a complex exercise, if you enter a workshop, you just look around. Is the machine running? Is the machine turned on? And if she's turned on and not running, if you look in that situation, what you find is that in a big number of cases, the machine is standing still because there is a tooling issue. If a machine is running but not optimized, and if you dive in and if you see, why is this machine not running in an optimized manner? Well, in a big number of cases, you'll find out it's again the tooling that causes this situation. And a metric a lot of people use when we talk about production excellence is that so-called OEE, overall equipment efficiency. And the thinking here is, okay, I have my machinery available 100% of the time. And in the end, I look how much percentage of the time, here completely to the right, the machine is effectively producing correct workpieces. That's what we refer to OEE. And in between available and being effective, producing correctly finished workpieces, you have losses, time losses. Some of them are planned, some of them are not planned. Machines are standing still because they need to be prepared for the next batch. The so-called setup time. Machines are standing still because there are problems. Machines are standing still because there is a speed loss. The reality is not as fast as the engineering thought it was going to be. You have breakdowns. You produce workpieces which are not correct, which is a waste of time. And in the end, you have what people refer to the OEE in percentage. And if you look in school books, people spend a lot of time talking about OEE of 96 or 97%. Very nice. If you look to the reality in machining production, which is today nearly always a small batch situation, well, you end up with an OEE of 20%, you are good. That means in small batch machining production, 80% of the time available from a machine is lost. And if you dive into what is going on, what you find is that most lost factors relate to the tooling. My machine is standing still because I have long ships. Yeah, why do you have long ships? Yeah. My machine is standing still because I broke a tool. Yeah, why do you break a tool? My machine is standing still because I'm checking because the surface roughness of my workpiece is no good. Yeah, why is the surface roughness of your workpiece no good? I think if I say 20% OEE, that means you have 80% loss. To my experience of that 80% loss, 3/4 is related to tooling. That means that 60% of your available time is lost due to tooling issues. That's not a detail anymore. Eh? And if you look to tooling in the full process, because machining is a bit of an issue, you have so many things playing together to achieve your machining or your production excellence. You have the tools you selected, you have the machining strategy, you have the cutting data you selected, you have the operators being there. And as I said before, they play a crucial role, not to select tools, but in using tools in the best possible way. And it's a lot of things playing together, but if you really go to the center, the machining process, where the actual cutting edge is in contact with workpiece material and is cutting material, creating a machine surface, and if I put against that all the targets we can have in a company, cost efficient, productivity, sustainable production, make sure you respect your delivery time, and so on, we have to control that machining process, and we have to control all those phenomena taking place in this process. And if that is what you want to do, what you find out from a very technical manner of thinking, that it's a balance game. You have to balance the capabilities of the tool you selected against the demands of the process you have in mind. And if you manage to balance those two, with other words, if you manage to have the correct cutting tool for the targets you have, job done. To be able to do this, you need, of course, skilled people. And I go here far beyond pure the operators. I involve the engineers. I involve management in this. And you have to give them the tools to evaluate their job, their work. I talk here of tools like evaluate the ships which are formed in a structured way. With a metric, with a tool we refer to as the global ship formation analysis. We have to look at the used tools with the GTDA study, with the GTDA project to see, okay, tools in reality, what happened with them? What was the machining reality, and what can I learn from that? You have to check the process quality with, for instance, a GPQA approach. How well do I manage that my process is functioning well? And if you put this in an economic perspective, so you have the technical performance, now we put it in an economic perspective, there are a number of levels here. Management has to decide how they define production excellence, where they want to be better than their competitors. That's a management decision. Is this about cost structures? Is this about productivity? Is this about energy efficiency? Whatever. There are multiple approaches here. And I don't take a decision of this is a good one, this is a bad one. That is the task of management. That's company strategy. How do we want to differentiate from our competitors? Once that is decided upon, then it's to the engineers, and I take here the example of a company, and that's still today the most common, a company that says, from a pricing perspective, I want to be attractive to my customers, so I need to keep my costs under control. I want to minimize my costs. That can be then a target for engineering. Build up your machining as such that we minimize costs. I go very fast here just to give you the impression, but if you look to the costs related to produce a workpiece, you have your tooling costs, you have your machining costs, your salary costs. They are depending, the horizontal axis is cutting conditions. They are depending on which cutting conditions you combine with the tool which has been selected by management. And what you find out if you combine those costs, that there is somewhere a point where costs reach a minimum. If you look to productivity on the other hand, which is how many parts do you, good parts I should say, do you produce per hour, per day, per whatever, or if you only have to produce 2 parts, how long does it take to produce 2 parts? Think on small batch reality. And then if you look to that, there is somewhere a set of cutting conditions for a selected tool that corresponds with lowest costs, with highest productivity, and those can be determined. And in these things, and it's not about the formulas here, but here, if you go to minor costs, minimum cost, you see that tool costs influence that. And this is the part where the 3% you spend on your tooling suddenly is growing in importance. If you look to maximum productivity, very interesting to see is reaching maximum productivity is not affected at all by the cost of tooling, but is affected by something much more important in this respect, and that is the skill level of the operator. How well is an operator capable of handling tools in a professional manner? So if you go for productivity, the cost of the tooling, the purchasing cost, become completely irrelevant. If you go for minimum cost, of course it's becoming important, but don't talk about that 3%. It's much more than that. And if everybody did his or her job, if management decided this is the concept of the tools we go for, if engineering translated that concept to the best of their ability in the correct tool features, the carbide grades, the geometries, the dimensions, the solid carbide over inserts, all those feature things. And if they came to a set of cutting conditions that are as such that it should work, allow me to say in theory, then it comes to the operator. And then the operator, because in the picture you see, I haven't explained, but what you see here is kind of for a selected tool on a selected machine in a certain job. What is the window of possibilities of that tool when it comes to cutting data? And as always in machining, the best cutting data are the ones on the edge. The tricky part is if you are constantly on the edge, the red surface there in the picture, there is a possibility that due to circumstances, who knows which ones, that you are suddenly beyond the edge. And that's when the operator starts to be very important, because he should recognize that, oops, we are too far. We have to go back a little bit. And that's the role of the operator. Machining economics is management. Tool selection is there, basic tool selection. Once you selected a criterion, then it goes to engineering, and engineering has to fill in all the details, the features of the tool, and come up with a basic set of cutting conditions. Thirdly, it's the operator that then looks into what's going on here, and where do I need to correct things to make that the process is stable. tooling decisions, what's a good tool? I give you a couple of seconds. Fill it in the comments if you want. What is for you a good tool? Is it long tool life, low price, high productivity? What is a good tool? But everything is good, but the answer you get is depending on who you ask the question. On a broader perspective, what would be a good selection tool or a strategy to select tools? Should we go for standardization or specialization, flexibility, low cost per edge, maximum productivity? What is a good tool concept? Should you go for insert-based tools or solid carbide milling cutters? What's good? How do you select? But also here, everything is good. But it depends on who you ask. And now we come to the core of the thing when we talk about tool selection. If you put 20 experts in a room, the answer to this question will be 20 different tools. And that's why I'm pushing so hard that management must take his responsibility. It's up to management, because management, those people know what the targets of the company are, what the strategy of the company is, how they see the future of the company. Well, those people should define what a good tooling system is, not filling in the details. I have had a discussion with a general manager. He said, but come on now, I don't know, not really, nothing from tooling. How do you want me to select carbide grades? No. Select carbide grades, that's for engineering. But as a manager, you know what you want with your company. And you should find out which tooling concept fits best for you to fulfill your company strategy. And this brings me to that I hope you start to feel that tooling is really something important. It's much more than the famous 3% of the total cost. So it's consumables. Don't spend too much time on it. Just buy the cheapest possible on the market. And if there are doubts, ask the operator, because he is the expert. Part 2 in this series is about, okay, how does management now defines good? What help do we have there? What tools are available for management? That's going to be the next session in this series. Once management decided good, without filling in the details, that's not for management. That's why they have engineering. Engineering has to fill in the details, the features, to make that correct, that good works. Then it goes to the operations, to the operators. And as always, you find when you start to think in optimized situations in machining are on the edge. And reality can hit hard there when you are, due to circumstances, a little bit beyond the edge. That's where the operators step in. That's where the operators needs to change things so that the process is stable. The operator should not select. The operator should make that the selected concept and features do work. But of course, there's a part 5, and that's closing the loop. That's the circular aspect. Operators should, of course, feed back, saying in that situation, it was for me impossible to come to a solution. So engineering learns and does better in the future. And engineering should also feed back to management. And saying, yeah, whatever target you came up there, Mr. Manager, in our workshop with what we have, we can't make it work. Also, that feedback is needed. And then it should roll. But that's for the next sessions. I tried, and I hope I succeeded, to convince you that tooling is the basic first step select good tooling is board level, is management. Tooling is not a detail, you know. Tooling is really perhaps the central production lever. Nah, most probably I'm exaggerating now, but it's an important one for sure. Most losses you have in production are tooling related. It's not always recognized. Think on OEE. People, oh, the machine is standing still. Oh, why is the machine standing still? Yeah. Whatever machining economics the company goes after when we talk about production excellence. Is it economical? Is it sustainable? Is it circular? Is it energy efficient? Whatever. Uh, it that decision needs to be supported by the correct tooling decisions, because tooling is where everything comes together: the physics of the process, the economics, the organizational wise, people involved in the process, and so on. And there are four perspectives. I repeat it again: management. The role of management in a company is steering the company, and in that steering the company, part of the thinking needs to be done related to tooling. Uh, and equipment around tooling. Once that decision is taken, okay, we go for this strategy in our tooling selection, we go for standardization, or we go for flexibility, we go for specialization, whatever. Then it's up to engineering to do the tactical part, to fill in the details, to find out the features, to come up with cutting conditions, machining strategies, that type of stuff. And then it goes to the operators that put everything now in the reality, observe reality. Of course, they need to be able to observe reality with the correct interpretation of what they see. And that is an example for me of the role of management. Management is not just that's the type of tooling we go, but management is also asking the questions: if we go for that type of tools, do we have the people knowing how to work with these tools? If not, we need to take that into our discussion. Operators needs to observe, give an interpretation, correct when needed. And all of this needs to be in a circular feedback modus. Everybody needs to give feedback to the previous stadium, and the previous stadium, operators to engineers, engineers to management, needs to be able to take it in, digest it, and improve, and then go back again. So what would I like you to do or stop doing tomorrow? Stop selecting tools from catalogs without knowing what exactly is good. And I'm not talking about what is a good carbide grade. I'm talking about what is a good tooling concept. A very typical example: do you go for milling cutters with inserts, or do you go for solid carbide milling cutters? Without the carbide grades and stuff, that's for later, but the concept. And start questioning who defines your tooling strategy. It should be management, nobody else. Look at OEE next time with the tooling hat on. Yeah, the machine is standing still. Yeah, the machine is slower than expected. Yeah, we have a lot of breakdowns. Yeah, the workpieces are not correct. Relate that to the tooling which has been used. And in the people present here, management start preparing for next session, because it's easy for me to say management must decide what is good. Yeah, but you need also help and tools. I hope my target was, and there is, if you want a copy of this presentation, I always say that if you want a copy of this presentation, let me know. You can have a copy. If you want other printed materials on machining subjects, tooling subjects, just let me know, and we see what we can do for you. Tooling is important, despite that people say, but it's only 3% of the costs. stop thinking like this. Tooling goes far beyond the 3% because the 97 other percent are influenced by the tooling you selected. At this moment, let me check. Do we have questions? Oh, as was to be expected, a lot of questions. Let's make an agreement here. I want to respect the timing because I suppose you also have a planning to respect. I have only a couple of minutes left, I see. I try to answer some questions. All the other questions later on in the comments, I'll give answers there. The first question is purchasing department qualified 5 companies for cutting tools. How do you choose the right CNMG 120408? Actually, how many are available? How do you choose the right one? And what about I love this question because this is exactly my point in this presentation. The question, how many CNMG 12, 04, 08 are there available on the market in different carbide grades, in different geometries, in different dimensions, 08 or a 12 or a 04? I think I'm not exaggerating when I say thousands of them. Tens of thousands is exaggerated, but thousands of them are available. If you have to select the one which is good for you out of thousands of different options, even if already it's brought back to 5 companies, if purchasing, and I wonder why it was purchasing and not general management, because purchasing bases itself on purchase prices, the 3%. Is it correct that purchasing should select suppliers? Shouldn't first management select suppliers? But anyway, even if there are only 5 suppliers, and if you directly go into details like carbide grades and so on, well, good luck to production. You have to test them all to figure it out. That's going to take you days, weeks, months. You need more. You need a strategy here. What do you expect from this tool? High performance, energy efficiency, long tool life. What do you expect? And that needs to help you to take down that testing time to an acceptable level. I don't know who asked the question, but really, thank you for this question. This is exactly what this presentation is about. Purchasing department. I question if purchasing department is the correct one to decide which tooling companies, tooling suppliers, the company wants to go into a strategic alliance with, because purchasing is about cost, purchase costs. Another question is, do you believe customers should provide the tool specification or process application to suppliers? Somewhere in the relation, yes. But that can I keep that to the next session? Let me answer like this. Management needs to decide what type of relation does management wants with the supplier. Do you want partnership? Do you want just buy and sell relation? The vendor relation, you know? I have a tool and it costs so much and I buy it from you and good friends. What type of relation do you want with your suppliers? That's up to management. And depending on the type of relation, the exchange of information back and forth is part of that. Because the one asking this question says, should customers provide tool specifications to the suppliers? Is one direction. The other direction is, which type of information should a tool supplier give to the customers? I gave the example that for management, it's important not only to select a tooling system, but also to ask the question, are my people capable of handling that tooling system? Well, that could be part of the relation you have with your supplier. If as management you estimate that your people don't have the capabilities to work with that type of tooling, well, a partner supplier should take that on board and make sure your people have the skills needed to work with the tools. But that is something you cannot expect from a vendor relation, because that's commercial shoving of tools. Here you have them, pay the invoice, and over with. It depends, back and forth, and what type of relation do you want with your tool supplier? Tool suppliers perhaps should also ask the question, what type of customers do we want? How is because it's also here about back and forth. There's feedback in both directions. And I see time is moving fast. Just one more question. If the workpiece meets quality specifications, doesn't that mean that the tooling decision was good enough? Of course it was good enough. In the end, you do what you are supposed to do, produce correctly finished workpieces. The question, of course, is at what price? And I don't mean money. I mean, to come with correctly finished workpieces, how long did it take? Did it jeopardize your sustainability targets? Wasn't it frustrating for your operator? All that type of stuff. Of course, if the workpiece is good, that's. But in which circumstances did you came to that correctly finished workpiece? Did you destroy first 3 others before you had the correctly finished one, as an example? And in that respect, tooling is good enough when somewhere you have a correctly finished workpiece, but the question is, the circumstances, could those lead you to a better choice? But again, yeah, that is feedback that has to go to management. Okay, we managed to correctly finish the workpiece, but this and this and this and this happened along the way. And that is feedback management has to take in and think about to come up with better choices. The other questions, as I say, I promise you, I'll take them later on in the comments. First, concrete things from this presentation to remember. The first thing to do in any selection procedure for tooling is defining what is good. What is good for your company? Not just what is good for your company. And before you start, don't start tomorrow to change things. Ask the question, what is good? And look to the reality. How is the situation today in your company? Don't change it. Just observe what is the situation. What are the real objectives? Because going out to engineering, we want to have good tooling. Yeah, that's not enough. You need to define it. Is it stability, productivity, flexibility? What you need to make it concrete. And in your mindset, tooling is not a detail. I know it's only 3% in the purchasing process, but that's irrelevant thinking here. If that mindset now is there in your head, the next step, the next session will be about management. Tooling performance, however you define performance, is defined long before you open a catalog. And that's what I wanted to say with my title. If you don't have created the correct definition for your company about what you expect from your tooling, whatever thing you select in the catalog is most probably wrong. Seeing the multitude of possibilities you find in catalogs. Define what is good. Good for your company. And management once that is done, have to translate this into a strategy and hand it over to engineering. Don't make the mistake. Don't misunderstand me. I did not say that management needs to decide on carbide grades. Absolutely not. That's why we have engineering in a company. But management has to come with a definition of a good tool for my company, for our company, and which strategy do we build on that? A little bit later, but I hope it was an interesting session. My mission was very straightforward. Take your attention away from the it's only 3% into it's the most important lever in your production. That's an exaggeration, but it's a very important element. It's not a detail in how you shape your production so it fulfills your company targets. Next session is tooling strategy definition for management. How do we define on management level what a good tool is and what a good selection strategy is for tools? Looking forward to meet you there. Remember, a good tool cuts metal. That's for the technical people. But a smart tooling strategy builds a competitive company. Thank you.